We have a decimal number system that uses place value to create numbers of any size. It's a system you can make numbers that go as big as you want and also as small as you want. So any number whatsoever can be represented in this number system. That's not always been the case. Earlier number systems in history, you needed to keep inventing more and more symbols to get up to higher and higher numbers. In our decimal number system, we have only 10 symbols. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you count them up, there's 10 digits there, 1 through 9, and also the 0 here, so that's 10. Okay. How can you represent numbers of any size if all you have to work with are 10 digits? Well, you can construct bigger numbers by moving these digits over to the left, and the further you move it to the left, the bigger the number it is they represent. So like for instance, if I put a 5 right here, that represents 5. But let's just pick this up and move it over here. If I put a 5 there, it represents 5 tens, or in other words, 50. And we put a 0 here, and the reason we put a 0 there is just to say there's a place here. I'm talking about the second column over. So this place is worth 10. Each digit you put here is worth 10. Since we have a 5 there, that's 5 tens, and that's what we mean by 50. If we put this in the next column, it represents 500. And so we've used 2 zeros to mark these places. These are called placeholders. And the reason we use them is so that we know that when we write the 5 and there's nothing after it, that's not a 5, that's 500. Here's the ones, the tens, and this is the hundreds place. So every time you move the digit one place to the left, it makes it worth 10 times as much. So 10 is 10 times as much as 1, 100 is 10 times as much as 10, 1,000 is 10 times as much as 100. Now, we can extend this number system to fractions as well. Rather than writing whole numbers in one kind of a system and then some sort of a fraction notation like this to represent numbers smaller than 1, we can continue this system itself to represent smaller numbers. Let's see how that works. Notice what I've done is I just put a point, and this is just a marker to say this is the end of the whole numbers, and everything beyond this are going to be numbers smaller than 1, or we also call those fractions. And because we're talking about fractions within this system, in other words, numbers that are smaller than 1 within this system, they're called decimal fractions. Okay? And so sometimes you just call these decimals out here, but what they really are, these are decimal whole numbers, and these over here are decimal fractions. That's a more correct way to say it. So let's see what we mean by that. If I start here at something like 100, and then this is 1/10 as big as 100, that's 10. This is 1/10 as big as 10, it's 1. But why not keep going? This is 1/10 as big as 1. This is 1/10 as big as that, and this is 1/10 as big as that. So I can go to not only larger numbers on this kind of a system, but also smaller numbers. Okay? So if I write the digits 1, 2, 5, what that means is this is 100, and 2 times 10, which is 20, and 5 times 1, which is just 5. So it's 100, and 20, and 5. That's 125. But what if I moved these over one place? So let's put them over here. This now represents 1,250, but the way I can know that it's in that place is I put a 0 here as a placeholder that says this is the 4th digit, not just the 3rd. So here's a 1, 2, 5, and I have to put a 0 to say here's where the ones are. Okay. Now, you don't need to put the decimal point as long as you're talking about whole numbers. But what if I want to include numbers that are smaller than 1? Let's take these same digits and move them down here. So now I have 125. If I move them down again, notice I have 1 in the tens column, that's 10, and a 2 in the ones column, that's 2. So 10 and 2 is 12. You recognize that as a 12. Then it says point, and here's a 5. Okay, what does the 5 mean? Well, this is 5/10ths. And 5/10ths is like a half. If you wrote down the fraction, 5/10ths, you could reduce it. Both are divisible by 5, and it comes out 1/2. So this represents 12.5. So you would read this 12.5 or 12 and 5/10ths. There's different ways to say this, but that's how we can represent whole numbers and fractions all within this system. So I can make smaller and smaller fractions by putting the digits over here to the right further and further. I've created a little demonstration to show how these values work. So in this demonstration, I'm just showing what the value of a 1 is in each of these places. So here's a 1 times 10, here's a 1 times 100, and so forth. Let's watch that now. Okay, what I've made here is a graphical way to understand the place value system. This line here indicates the dividing line between whole numbers over here and fractions over here. When I say fractions, I mean numbers smaller than 1. So this column represents ones. These numbers are bigger than 1. These numbers over here are smaller than 1. So let's go through these and see how they work. So if you have a 1 in the ones place, this little bar right here shows you how big a number that is. This is 1. And notice on the scale this says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so you go over to the second column, and this shows how big the 10 is. The 10s is 10 times as big. So if you put a 1 in this column, it represents this big a number. And notice on the scale it says 1. If you put a 1 in this column, it represents this big a number, 10 times as big. And notice the number over here, it says 10. And notice the way the 10 is written, 1, 0. That means there's a 1 in this place, and there's nothing in this place. So this column here is 10. What about the next one? That's going to be hundreds place. Let's see how we can get to that. So what I'm doing here is I'm just zooming out until I can see the top of that column there. So this is what a 1 in the hundreds place looks like. Down here is the 1. I just zoomed way out so you could see it, and that 1 looks tiny by comparison. This is 10 times as big, and this is 100 times as big. Notice the hundreds column, this is 10 times as big as the tens column here. So if you have a 1 in this place here, so like 1 followed by 2 zeros, 1 here, 0 here, 0 here, then this is how big the number is compared to this size number if you have a 1 in this place and nothing in this place. Let's keep going and see what the next column is. Okay. If I zoom way out, I get to the thousands place. 1,000, here's the way you write 1,000. That means 1, 0, 0, 0. So this is the size of 1,000 compared to 100. It's 10 times as big. It's 100 times as big as the 10, and it's 1,000 times as big as the 1, which is why it's called a thousands place. So here's 1, 10, 100, 1,000. You can't even see the 1 anymore. That's just microscopic. Okay, let's keep going. 10 times as big as the thousands place is the 10,000s. If I keep going, 10 times as big as the 10,000s. Notice this is 10 times this. That makes this 100,000. And 10 times as big as 100,000 is a million. There's a 1 followed by 6 zeros. That's 1, 0, 0, 0, 0, 0, 0. All those zeros are placeholders so that we know that the 1 is in this place way over here. And so it represents a million compared to these much smaller numbers down the scale. Okay, so let's zoom in. And so from a million, we come down 1/10 as big to 100,000. We keep going till we're 1/10 as big to 10,000, and then 1/10 as big to 1,000. Go 1/10 as big down to 100. Go 1/10 as big down to 10. You go a tenth as big as that, you're at 1. But we don't have to stop there. We can keep going. Let's go down to 1/10 as big as the ones, and we have tenths. So over here, we're now getting to numbers smaller than 1. And so if I do the same pattern, every time I'm going 1/10 as big as this size number, I get to the next column. The next one represents hundredths. The next represents thousandths. Let's pause a second. Notice how a thousandth is written. It says it right here. It says 0.001. Now, whether you put that first 0 or not is optional if you're writing it. You could just say 0.001. When they print this type of thing, like in books, they usually put that leading 0. And the reason for that is so that you don't lose that decimal point. If you start with a decimal point, it's easy to miss it sometimes. So what that 0.001 means is there's no ones, there's no tenths, no hundredths. That 1 is over here representing this column. This is how big it is. 1/10 as big as a hundredth, which itself is 1/10 as big as a tenth, which itself is 1/10 as big as a 1. Let's keep going in. So a tenth as big as 1,000 is a 10,000th. Then 100,000th is 1/10 of that, and a millionth is a 1/10 of that. This represents a millionth. It's 0.0000001. 5 zeros and then a 1 would put you at a millionth. Okay, so that's the way the place value system works. The reason it's used is we can represent numbers of any size. We don't have to stop at a million or a millionth. We can go way beyond millions. We can go way smaller than millionths. You can go to billionths and trillionths and so forth, on and on and on. There's no limit to how big a number you can write in this kind of a number system.